So essentially, your functions, that arrow on this in this mapping diagram is indicative of whatever function is happening. So your function could be anything. Could be like a function of x squared could be happening now. Now, that domain where you see x in is at. That means you can literally put your x as, for instance, 1 to 5. So now, if the function was x squared, that means the arrow was representing x squared. That means once you take x as 1 through that function of x squared, it will bring out an output of 1. If you put x as 2 through that function of x squared, it will bring out 4. If you bring x as 3 through that function of x squared, it will produce 9. So that x that you are imputing, the input variable, is the domain. I believe that's clear. Now, let's talk about the codomain and the range. The range is the response that you get from each value in the domain. Let me say that again. Your response, the output that you are getting once you fix in a value for x, that's the range. So if I fix value, let's say my x was 1, 2, 3, and the function was x squared. That means my range will be 1, 4, 9. Because the response from putting 1 into x squared will be 1, putting 2 will be 4, putting 3 will be 9. So obviously we'll be dealing with the range of 1, 4, and 9, which is the response from the domain being imputed into the function. So then what is then codomain? Codomain is like an overall possibility. Overall possibilities that could occur. For instance, now let's say our domain represented set of integers. Let's even be more restrictive. Let's say set of positive integers. Positive integers, we have 1, 2, 3, 4, 5, and so on. Now, but let's assume for the specific discussion you are having, we were using just x as 1, 2, 3. Now, obviously, we're using x as 1, 2, 3. When we pass it through the function, we get the range of 1, 4, 9. But the codomain is still larger than 1, 4, 9. That's if the domain represents set of positive integers, that means your codomain is quite larger than 1, 4, and 9, which is the range. So that codomain is like the set that contains all the possible values that the domain was defined on. So if your domain was defined on the set of positive integers, your codomain obviously would mean you fixing positive integers into x squared. But based on the particular question you're dealing with, you may be dealing with just a particular aspect of the positive integers, maybe just 1, 2, 3. So in that case, 1, 2, 3 is your input variable for that particular question. But there are other possibilities as positive integers, which is where your codomain will be represented. So let me say this quickly. Most of the time, you don't deal with codomain when you're dealing with mapping. Most of the time, what you have is your domain and your range, because your codomain sometimes is always represented sometimes with boundaries. So you may not be able to specifically exhaust all the elements of your codomain. So most of the time, the range is the most finite possible response you can get. So that's just the understanding I feel you should have about domain, codomain, and range. The domain of a function is a set of numbers to which the function can be applied. So those sets of numbers, those x variables, those independent variables to which your function can be applied. That means you can put in x as something, maybe x as 1, 2, 3. That's your domain. The set of numbers that are assigned to the independent variable, that's actually still your domain. Now, range of a function is a set of numbers that the function associates with a number in the domain. As I said, whatever your response from your particular numbers you put into the domain, your input variables. The response, the particular response, specific response from them is your range. All right. In the next video, we'll be talking about some certain examples that will help you to define and determine the domain and range of functions. All right, guys. See you in the next video. Bye bye.